Tonight we're going to look at the XTAR PB2 handheld portable charger. This will charge two 18650 lithium-ion cells, and it also functions as a power bank in a very compact and user-friendly package. We're going to take this one apart too. Let's check it out. Got another battery charger to show off today. This one came in for a demo. This one's shaped more like a power bank than a battery charger, but it is actually both. It's a battery charger and a power bank, and it works with the standard 18650 lithium-ion cells. This one can hold two. The beauty of this little unit here is you can load your cell in here, and it accepts 1 or 2 amp charging. You can load 2 cells if you like, so if I have a second cell out of my flashlight, cover is magnetic, so that'll hold the cover shut. Now it has the ability to charge your phone, and it's also a charger. So we have 5 volts input to 2.1 amps, and the output is 4.2 volts at 1 amps times 2 and 2 amps times 1, looks like. That's for the charge the batteries. And the USB output is 5 volts at 2.1 amps. On the side of it here, there's a button. You press the button, it'll tell you the capacity of your batteries. So I have 74% charge on these batteries. 2 ways to operate this. If you're going to charge your batteries up, you would connect the USB cable to the input and then connect this to your charge source. I'm charging at 1.88 amps. I'm using the all maybe supply for this, and it's now charging my cells. It'll charge up the 2 batteries that are in here and stop when they're done. So you can see we're at 76% now. So we'll just let this thing charge here for a bit and let these cells charge up, and then we'll try it charging a cell phone. So basically how it works is if you've got 1 cell in here and you're using it as a charger, which I have 2 cells, so it's going to charge these cells at 1 amp each. If I remove one of the cells, then it would charge the remaining cell at 2 amps. What's neat about this, and I like this, is that if you can carry this with you as a cell phone charger, and you can swap batteries out, right? So if you've got a couple of these batteries that you've got charged, you can swap them out, and you don't have to plug your cell phone charger in to charge it up. If you're carrying something like this with you to keep it in the car to, say, charge your cell phone, if your battery goes dead, you can have an external charger at home and keep your cells charged and just carry the cells with you and use just as a power bank. Whereas in a conventional cell charger, how many times when you go to use your cell charger, you find that the battery in it is dead because you've used it and you forgot to charge it up. I know that doesn't happen really to me that often because my cell battery never goes dead on me. But it certainly happens to my daughter all the time. She's got a little power bank, and she'll forget to charge it because she'll use it to charge up her cell phone, and then she'll forget to charge the thing, and then of course she's caught with a dead battery and a dead power bank. So having something like this for her would be quite useful because you can pick up these batteries pretty reasonable and just carry a few of them around, and once you've used it, just swap the batteries over, put a fresh one in and take the other one out, which makes keeping one of these things topped up pretty quick. Anyway, I'm going to let this thing charge, and we'll see. As you can see, it's at 85%. Now, these batteries weren't dead, so they're not going to take long to charge. We'll see how much capacity we get out of these things, and then I'm going to proceed to charge some stuff up with it. I'm reading through the instructions, and I guess some of these companies are concerned that there's people making counterfeit products of their product, counterfeit devices. So how can you tell if you get one of these units if it's a real one or not? Reading the instructions, they call it anti-fake. On the back of the package there's a sticker right here, and if you scratch the sticker, it says anti-counterfeit. If you scratch the sticker, there's a number that gets revealed, and you can go online and you can put that number in, and it will tell you, if as it says here, it says scratch the anti-counterfeiting label on the package and input the number into the query page at www.xtar.cc, and it will tell you whether that product is one of theirs. I'm covering this up, obviously, this number, so that you guys can't see the full number, but there's a number on here that can be queried to see whether the unit is on their website, to see whether you've got an original, authentic unit produced by the manufacturer or whether you've got a counterfeit. That's kind of cool that manufacturers are now starting to tackle this counterfeit device, because something like this, a device like this, you really don't want a counterfeit device, something that's containing lithium-ion batteries. Lithium-ion batteries, if they don't have the proper protection circuit, they can burst into flames. So anytime you're using anything with lithium-ion batteries, you really want to make sure that the device that you're using is an authorized device and it's been properly engineered and not some cheap knockoff. So it's good to know that the manufacturers are giving us ways that we can check to make sure that what we've purchased is an authentic product and not some knockoff. Anyway, I'm going to shut up for a minute while this thing charges. Just to explain the display, single digit means it's charging right now. When this is not flashing, it's in the discharge state. And according to the manual, if you put two batteries in and they're at a different charge state, it will charge one battery first until it gets to the same state as the other, and then the two of them will charge up together to get to full. Also, on the product itself, there's another label here. It says scratch inquiry. This is where you would scratch to reveal the same number that's probably printed on the box here. Nope, it's a different number. Anyway, so that way you can verify that the sticker on the back of the box has a number on it. The sticker here has another number on it that you can put on the website to verify whether this device has been one that's been counterfeit or not. I think that's kind of cool. More companies should do things like that, where you can check and see whether what you bought is real or what you bought is a knockoff. That would be, if more companies did that, we wouldn't have the problem with the copies out there of really poor quality, because there are good quality products and there's junk, right? And nobody wants to get stung with junk. Okay, the cells are at 100%. They took, if we look on my other little charger here, they took 855 milliamp hours to charge, and you can see the charge current's gone down to 0 because the charger is shut off and plugged. Now we're ready to charge up a device using the output port. Now I'm going to charge up my USB-C device, so I've got my USB-C charge cord. Plug my phone in. And my phone's now gone on to charge. We're at 47%. 48%. I'll let this thing charge up here and we'll see how long it takes to charge up my phone. According to the internal charger, it should take about an hour and 5 minutes to fully charge my phone at 48%. So we'll let it run and see whether it charges up in an hour. As you can see here, the time on my phone, 11:44. So we can time it and see how long it takes. It should be charged in just over an hour. As you can see, 12 minutes remaining. We're at 94% now. We're getting there. It should be charged up momentarily. There we go. We just saw it flip over to 100% charged. So now the charging circuit should shut down on here. There we go. And it just shut down as it's no longer needed. My cells still have 45% of their charge. I'm going to plug this back in here and we're going to let this charge up overnight. And it's now charging. It's charging at 1.86 amps. We're gonna let this charge up for the rest of the night. I charged my 2 cells again to full capacity. As you can see, the 2 cells took 1977 milliamp hours to bring both of them back to 100%, but I think they were like, what, 50 some odd percent when I was done. So these are charged up. I think what we'll do now is I'm going to see if I can take this thing. I don't know if it'll come apart or not, but I'd like to see if we can get into this thing and see what's in it. It looks like it's might just snap together. We'll see. I can just see the people clicking the thumbs down now because I'm going to destroy this nice battery pack. I'm going to mark it up, I'm sure, getting into this thing, but we need to do this in the name of science because we want to see how well this thing is put together. And that's just how it pops apart, just like that. Just along the seam. I don't think I'll damage this one too much taking it apart. But we all want to see how well these things are built. You guys want to see how well it's built. So do I. And there it is. Got a couple screws that hold the little circuit board in place. Looks like I can remove them. It's 2 parallel charging circuits, as you can see. Got a common negative. There's my little button that just popped out there. Let's open up the circuit board here. Just take a look at the board. They've got some glue on here. Looks like this is silicone too. It's not hot glue, not hot snot. And the screws actually have little plastic washers on them, which is kind of neat. You don't see that very often. Let's see if I can just pop these down. And push the whole circuit board. Oh, it's got a clip on here too. It's got a clip on the top of the USB port. Interesting. I think we may have a winner here, guys. I think we may have a winner. Winner, winner, chicken dinner. Wow, let's take a closer look at the little circuit board here and see how it looks. So that's about as close as I can get to this. If I go any closer, it's going to go out of focus. But I think we still have a pretty good view of the circuitry here. I don't see anything that looks bad. I mean, the circuit board looks to be really well built. Good quality components. I don't see any issues with the soldering on here. Everything looks good. This is, of course, the top side of the board that has a display on it. I don't see a number on that IC. But we'll look at the other side of the board here. This is the business side. I think that's probably the boost converter for the 5-volt output. This is probably the boost controller chip too. What's the number on that thing? I can't see it here. It is a DTM. We'll look that number up, but a DTM 468 looks like. A 4602 maybe? DTM 4602. Should put some more light on here so I can see it properly. We'll just put one of the batteries I just charged up into my flashlight, because that's what these batteries are for, is for my flashlight. Okay, now maybe we can see that number a little better. Get in here with some more light. Yeah, that looks a little better. DTM 4602. We'll look up that chip and see what that does. But it looks like that's probably part of the converter. If we look at where the leads go, this is, I think, probably the MOSFET to drive the converter. If we look on the other side here, and this one's probably the charge regulator over here, this chip. We got a number on this one that we can see, or is it I don't see a number on that chip. I'm looking at the same thing you guys are looking at. I'm looking at the screen. The chip obviously has the display driver. You can see the traces that go over here to the display. But I think this is probably also our charge controller. It controls the two charge circuits which come through here on the positive sides here. Because this is our charge input, or power in for charging. It's going to be probably a resistive drop. Loaded drop, it'll charge it up at full power, but it'll regulate the current through a shunt to control the charging, I would think. Anyway, looking at this circuit board here, it looks flawless. Obviously those pins in the middle here that are not soldered, they're not soldered for a reason, because it's just a power port, it's not a data port. So it's not communicating with your phone in any way, it's just providing power to the power supply. If it was whatever it's plugged into, it's not communicating with it, so that's why the middle ports are not connected. I had this discussion with my 18-year-old know-it-all that refuses to charge his phone. A lot of times you'll go into restaurants and stuff, and a lot of the newer ones that are being built, because we've just got a bunch of new restaurants out here where I am, because there's a new mall that's gone out here, and a lot of them now have, right at your table, they've got a power outlet, and most of the new ones, the power outlet also has, in addition to the 120 volt socket, it also has the USB charging built in. It's built into the plug, and my Rocket won't use them. He says, "Oh, well, you don't use that. They're data mining. They're data mining your phone while you charge up." I don't know where he got that idea from. Probably off some conspiracy site. You know how a lot of the millennials are these days. They believe everything that they see online. Claims like the moon landing was fake, okay, and claims like, I'm going to hear it from people right now that are going to try and convince me that the moon landing was fake. Just wait and see. Watch the comments. Or that 9/11 was an inside job. That's another one. I love those ones. No, he'll convince you. Say you can't charge your phone up if you're in public because they're going to data mine your phone. They're going to steal all your data off your phone. It's like, right. Sure they are. When they only have two wires connected, they don't have the data ports on it, like plugging it into a computer. I mean, he could be right. Plugging it into an unknown computer, I would agree that, if someone had a laptop sitting there and saying, here, just plug your phone in here and charge your phone off of a laptop, then I'd be going, yeah, right. Do I look like I have sucker stamped on my forehead? But the power plugs that have USB charging in them are wired just like this. It's just the positive and negative terminals are connected. The other ones aren't. And then you can always use one of those charging cables only if you're concerned. Like even if you were plugging into a computer, you could use one of these little charging cords like this one here. This charging cord is not a data cord, as we found out when I did that amplifier review a while back, where I tried a charging cord and it wouldn't connect to the computer because I was using a charging cord, which only has 2 wires in it, not 4. Anyway, that's beside that. This unit looks to be really well built. I'm going to put it back together now, and I'm going to put this thing in service. I'm keeping this one. This is a winner, this one. Winner, chicken dinner. A lot of these things I review, I dispose of them after I'm done the review because I don't have any need for a lot of this stuff, and I give them away. Like a lot of those battery chargers, when I do a review on them, very few of the ones I'll actually keep for myself. I kept the Deska SQ4, the one that charges 4 batteries. I kept that one because that's a great charger. It's powered with a 120 volt adapter. So I kept that one. This is another one that I'm going to keep because it's a great unit. It works. It charged my phone quickly. I can use readily available A-size lithium-ion cells, which are dirt cheap. The ones that I was using here, these ones, were $4. I bought the $4 power bank at Dollarama here in Canada. It's $4. I ripped the power bank apart because the power bank itself is limited. It's a 1 amp power bank. Charge at 1 amp, it'll discharge at 1 amp. But the cell inside is great, and it's cheaper to buy one of those $4 power banks and rip it apart and take the cell out of it is cheaper than buying the cell directly. Because it's just a standard 16850 or 18650 as standard cell. And hey, the cells are good. I use them in my flashlights. I use them in anything else that uses them, and now I have another use for them. Carry this with a couple cells in it and keep it in the car, and that way if my battery goes dead on my phone, I can charge it up quickly. Of course, one test that I didn't do on this, which I think I probably should, is I'm going to do the load test. So this is my little test jig from the last when I tested out the little charger here, which we put to its maximum power of 2.5 amps. I'm going to see if this thing will actually power this thing up, and we'll just do some measurements here and see what it can accomplish. Let me grab my meter. We'll run this cell down. I'll just do it with one cell. Okay, I've got my current meter set up here in series with the load. So this will measure our total current. And as I connect it, we'll see that, oh, it shuts off. Why does it shut off? Well, because I didn't read the instruction book or instruction manual. See on the back here, it says USB output 5 volts at 1 amp or 2.1 amp. If you only have one cell in it, it will give you a maximum output of 1 amp. So you do need to use 2 cells. So there's a second cell. Let's I'm going to move these out of the way so that they don't burn anything, because these are going to get hot as hell, these resistors. And there we go. I'm pulling it under. My probes are connected backwards, but if I switch them around here, it'll go to the positive side here. But there we go. I'm drawing 1.84 amps on here. And it's interesting that my cells show that they're only 87% because I did charge these up. But I have got them under a full load here. And we'll see. We'll let this thing run and just see how quick it sucks these things down. It's not living up to its full 2 amp rating. However, I have to take into consideration the loss that I'm getting through the leads, because these leads are starting to heat up. Let me just take the meter, and I'll just take these test jumpers off here, because obviously they're adding resistance to it, and we'll just put the meter straight across onto the USB connector wire, because I know I can draw 2.5 amps because that's what this draws. When I tested this with the charger, without any meter in line, I was using the measurement capability of the All-Maybe charger. It was showing me that I was getting 2.5 amps, because when I went to 2.6, it shut down. So I'll remove those test jumpers, and we'll see that we're now at 2.4 amps. So that would explain why I was only pulling 1.8. That's the resistance of these. So if I want to test this thing properly, I'm going to have to just wrap my meter here and kind of just put it right on the resistors so that I get full current through here. If I can get it to here, we'll do this way. I'll just stick the wires in here. Because the meter can certainly pass the current, the meter probes. They're not going to cause a problem. But these other cheap, pack of 10 for $5 from the China store, yeah, they don't have the current handling. I'm backwards with my meter, but big deal. It says negative. you guys can ignore that. Let's just see how long it goes here, and we'll just run these batteries down. It's 4:14 right now. We'll take a look at the time, and I'll start my stopwatch up here, and we'll see how long it takes me to run these cells down. So for this test, I'm running the batteries down at maximum current through a current shunt. I've time-lapsed it, and we are running it at 100 times normal speed. So if we do the math on here, it was 50 minutes that the cells took to discharge at maximum current. And I did check it for temperature, and nothing got warm during the discharge cycle. It actually was a very safe discharge at maximum current. The unit itself and the cells didn't get hot. The resistors, on the other hand, they got hot enough to melt solder. I don't know if you saw me, but I was actually melting solder on the resistors there while this was completing, because they did get pretty warm, as would be expected passing that amount of current. Okay, I ran the batteries down. We're going to put them back on charge again. So there it is, the XTAR PB2 new generation handheld portable charger for 18650 type lithium ion cells. I think we got a winner here. This one came from banggood.com. The link to this unit is in the description. I like this one. I loaded it up to maximum discharge current. It didn't fail. It didn't get hot. I think we got a winner on this one here. Thanks for watching, and we'll catch you in the next one real soon. Bye for now.